Hello and welcome to Astro Morning Tea at ICRAR. I'm Luke.
And I'm Pikky.
And this week we'll be taking you through a rundown of all of the science news going on and the excitement that's been happening in the world of astronomy. So, Pikky, what are we talking about?
One very interesting, baffling discovery that ICRAR was involved in.
Baffling.
Yes.
Baffling.
Ooh.
Exciting.
It dismounts all the theories that we know about this particular...
All of them?
Yes, one very important
one very important
that we know about this particular kind of star. So have you heard about neutron stars?
I do know a bit about neutron stars, yeah. Not my area of expertise, more your area?
Sort of. So they're just a precursor to black holes. So they're as compact as a star can be. If you go anything beyond that, they're going to collapse and become black holes. So these compact stars, like Earth has a magnetic field, like the sun has a magnetic field, even these compact stars.
Your fridge magnet.
Yes. I'm just having images of fridge magnets on neutron stars now.
Yeah.
But so they are all supposed to have magnetic fields. Now, neutron stars, sometimes their magnetic fields can range from low to high. This particular neutron star had a magnetic field of trillions times of the magnetic field of the sun.
Okay.
And with such strong magnetic field, you would imagine that all of them, if it's the neutron star is in a binary system, accreting matter off of another star, you'd expect it pushes all of its matter to the sides. But for this particular star, even with such strong magnetic field, we found jets.
Okay, so the magnetic field is supposed to stop the jets from firing out from the neutron star.
Yes.
That's what the current theory says, right?
Yes, the current theory says that matter falls in, somehow gets close to the neutron star, releases that jets, but with strong magnetic fields, you can't let the matter get in. So you're not supposed to be observing these jets, but now we have observed, now what do we do?
And this comes from ICRAR, right? Some of this research?
Yes. One of our professors, Dr. James Jones, Professor James Jones, I can't screw that one up.
Oh no, you've demoted him.
No, he's my supervisor.
Oh, he's your boss?
Uh-huh.
Oh, you're going to be in trouble, that's it. No PhD for you.
No.
He doesn't watch?
I hope he doesn't.
You'll watch this one.
Yeah, he was involved in one of this. So a student from the Netherlands, summer student from the Netherlands had come to ICRAR. We had a very strong collaboration of work. He did some data analysis, and this is what came out. And now neutron star, people working with neutron stars, jets, they don't know what to do with this information. All theories disbanded.
Super exciting.
Yes.
So, news story I saw this week was about tiny robot rovers. Did you see this, about them landing on an asteroid?
I've maybe a little bit, yes.
Yeah, so the Japanese Space Agency, JAXA, has basically landed, I got it right.
Yes.
You seem so impressed with me then. Well done, Luke. They've landed 2 small rovers on an asteroid, which is called Ryugu, I think. If my pronunciation is terrible, probably. But they've landed these 2 small rovers, which is the first time that rovers have ever been landed on an asteroid. So we've had probes that have gone onto asteroids, but anything that can move, we've never landed anything on them before. And these 2, they're little, like, I think they look like Roombas. You know, like robot vacuum cleaners?
Yes.
They look like that, basically. And they don't roll round. They haven't got wheels. But what they do is they jump. So because of the low gravity of the asteroid, they can jump up to 15 meters and they can land on different parts of the asteroid. Now, the reason this is really interesting is because asteroids are thought to have formed in the really early solar system. So they basically have the composition of what the early solar system was like before the Earth formed. So understanding what asteroids are made of and how they work is very interesting in trying to work out how the solar system formed. So these rovers are on there and they're taking samples of the surface, and they're also doing some cool photos. Go and look online. They're really awesome photos from these the surface of these asteroids. And they're also going to land other probes on the asteroid from the same spacecraft later on next year and do lots of cool, interesting science. And they're going to actually try and bring back samples from the asteroid to Earth as well to analyze them, which is really cool. So it's an awesome story.
Yeah, I saw this. This asteroid is supposed to have carbon, hydrocarbons, and even water.
Yeah, it could potentially. It's
Does
super
that
cool.
mean we could be bringing back alien life?
I'm going to say no. Keep your fingers crossed though, maybe. I'm going with no. My money's on no.
Okay.
We'll have a bet.
All right, let's see.
We'll see what happens in a year's time.
I say yes. Let's bring in alien.
Let's do it.
Alien life on Earth.
We need to find some suitable thing that the loser has to do. Wear a stupid hat on AMC or something. Anyway, moving on to our question of the week this week. So our question this week comes from Cass, and Cass has asked, can galaxies change shape? So this week, ICRAR PhD student Hussein is going to tell us all about it.
So yes, the very short answer to this question would be yes, galaxies change their shape. We see galaxies in many different shapes and many different physics around us in local universe. We see galaxies which are so thin without any bulge, they are so disky, and we see galaxies which are the spheroidal shape of galaxies. But when we go so far from us and look at the galaxies at like 8 or 10 billion years ago, we see galaxies quite differently. Their shape is different, their physics is different, and everything is different. And when we follow the galaxies since then up to now, we see the shape of galaxies are changing. And today we see galaxies with different shapes, with different physics and different size and different population of stars in different components of galaxies. So yeah, the galaxies have different shapes, and their shape and their size will change over time.
Thank you, Hussein, for that question. Now into the random fact of the week.
You're always so surprised that
I
it's going to
keep
happen. You
forgetting
know
what
that it's going to happen. We have the same format every week,
I
Pikky.
know, I'm not-
Stories, question, random fact.
Not a good sign.
You're not learning quick enough.
No, I'm going to
It's okay, it's okay. We'll get there, we'll get there. Okay, random fact of the week this week is, Pikky, what is the best way to abuse diplomatic immunity?
Call them intelligent. I'm sorry.
So, Hollywood would have you believe that diplomatic immunity is like this thing where you have people murdering people and drug smuggling and things, and then hiding away and saying, you can't arrest me because I have diplomatic immunity.
Yes.
In reality, it's not quite as exciting. So diplomatic immunity is basically says that diplomats in foreign countries can't actually be tried or arrested even for crimes in that country. And there's this rule basically around the world that if you're a diplomat in a certain country and your family, you can't be tried for crimes in that country. It was originally set up so that foreign countries couldn't falsely accuse people of committing crimes to try and get the ambassadors out of their countries and things. So they set up this worldwide system. But nowadays, the system is completely abused by traffic violations. So traffic violations is the biggest thing that diplomats do in other countries and do not care about. So you can get in trouble if you do pretty bad things. If you were drug smuggling, you could get ejected from a country, say, and then you get in trouble when you got back home. Traffic violations are so small things that countries wouldn't like cause a major international incident because of them, and they just get over them. But this means that diplomats all around the world are basically piling up massive traffic fines. So because the UN is in New York, the city of New York is owed tens of millions of dollars by diplomats in their countries because of parking tickets. So the one thing they could do is they could actually remove the driving licenses of diplomats.
Okay.
But there's then no law that says that there's no way that they can actually stop them from driving. So they can drive without licenses because they can't be arrested for driving without a license. And this basically means that all around in all major countries and in all major cities, diplomats are just ringing up massive fines. So there was an estimated that there was £20 million worth in congestion charges in London that diplomats owe and have never paid. I think the US alone owes £10 million, I think it was, to the British government in congestion charges in London. So if you are a diplomat, you're not likely to do any drug smuggling or murder and hide behind your diplomatic immunity, but you will get traffic infringements.
Considering the kind of crimes I commit, that would have been perfect.
You'd be perfect. You're getting parking tickets all the time.
Yes.
You need diplomatic immunity.
I do.
You should become an ambassador and then you'll be
Indian
fine.
government.
You have to just put a request. Is that it? Was that the request? That's good enough.
No formal
You're like,
application.
okay,
that should be
Pikky,
good
you're
enough.
in.
Yeah.
Okay, that's all we have time for this week. So join us again next week for some more Astro Morning Tea news.